Myself, Dr. Somir De, teacher in charge and assistant professor of mathematics section under Department of Basic Science and Humanities, Asansol Engineering College. This is my fifth lecture under module number 2 in determinant form. Topic is indeterminate form of LHospital rule. Module name is calculus differentiation. Paper name is mathematics 1A. Paper code BSM-101. This subject belongs to paper which belongs to BTech first semester, computer science and IT. So in my last video, that is lecture number 4, I had discussed LHospital rule 0 by 0 form, infinity by infinity form, and one special form, that is 0 in infinity form. So this is the extension of this lecture. Suppose if we have a infinity minus infinity form, so the form infinity minus infinity form can be reduced to 0 by 0 form. Then we apply LHospital rule. Let fx and gx infinity, gx tends to infinity, x tends to a, then limit x tends to a, fx minus gx, that is infinity minus infinity form, can be written as limit x tends to a 1 by gx minus 1 by fx by 1 by fx into 1 by gx, that is 0 by 0 form. So from here it is clear, if you have any infinity minus infinity form, so we have to reduce into this form to convert as a 0 by 0 form. Then we can apply LHospital rule to find the solution of the limit. Try to understand. Evaluate limit x tends to 0, 1 by x minus 1 by sine x. If I substitute the value x tends to 0, there is 1 by 0 in infinity and 1 by sine x infinity. So that means this is infinity by infinity, infinity minus infinity form. Then what we do, our target to reduce this infinity minus infinity form as a 0 by 0 form. What you do, very simple, take LCM, that is sine x minus x by x sine x. So if I check, if I put x equals to 0 to this expression, that is 0 minus 0 by 0. So that means I have 0 by 0 form. So already you know, if you have 0 by 0 form, by using LHospital rule, what do you do? Just differentiate and substitute the value. That is cos x minus 1. From here, cos sin x plus x cos x. That is it. This is the uv. X derivative is 1. Sin x remain as it is, plus x sin x derivative cos x. Again, if we put x equals to 0 to this expression, that is cos 0 is equals to 1, 1 minus 1, 0, and sine 0 is 0, and x into 0 something, 0 into something is 0. So again, you have a 0 by 0 form. Again, if we apply LHospital rule, that is cos x derivative is minus sine x, and sine x derivative is cos x derivative is minus x sine x from here, and cos derivative x derivative is 1, that is cos x. So from here, this is a sine cos, and this is a uv. X as it is, cos derivative is minus sine, and x derivative is 1. So that's why cos x. Again, you have 0. Here it is a 1, 0 plus 1. So from here it is clear, 0 by 1 minus 0 plus 1. There is a finite value you have. That is 0 by 2 is equals to 0. So finite value we are getting. So we can stop the calculation. So this is the result of this limit. Next example. Evaluate limit x tends to pi by 2 sec x minus tan x. This is also an important example for you. Limit x tends to pi by 2, that is infinity, x sine pi by 2, sec pi by 2 is infinity, tan pi by 2 is also infinity. So infinity minus infinity form. Then what you do, you have to take express 1 by type, that is sec, you can replace as a 1 minus cos x. My tan can be represented as a sin x by cos x. So ultimately our objective, there is no predefined rule, there is no hard and fast rule. So ultimately our objective, if we have infinity minus infinity form, first you have to reduce as a 0 by 0 form by any means. Take LCM or after simplification, whatever. So in this case, what we are doing, sec x can be written as 1 by cos x, and this tan x can be written as 1 sec x by sin x by cos x. Then you take LCM, that is 1 minus sin x by cos x. So from it is clear, if we substitute the value x equals to pi by 2, that is sin pi by 2 is 1, that is 0, and cos pi by 2 is 0. That is ultimately 0 by 0 form. Again 0 by 0 form. Again using LHospital rule, then what you do, that is cos 1 minus derivative of this Ultimately, sine derivative is minus cos, and cos derivative is minus sine. So from it is clear that if I put x equals to pi by 2 to this, so x cos pi by 2 is 0 and sine pi by 2 is 1. So ultimately what you have, your result is 1. Again another example, evaluate x tends to 1, x by x minus 1 minus 1 by log x. Let's see. If I put x equals to 1, that is 1 by 1 minus 1, that is 0, that is 1 by 0 infinity form. Similarly, 1 by log 1, that is 0. So again 1 by 0 means infinity by infinity minus infinity form. Then what you do? Same, our objective to express as a 0 by 0 form. Take LCM. That is x log x minus 1 by x minus 1 into log x. 0 by 0 form, very easy. Now, if you have a 0 by 0 form, then you have to apply LHospital rule. Then x into log x means derivative is 1 by x plus x derivative is 1 log x, and 1 derivative is minus x derivative is minus 1 by 1 minus x derivative is 1. So log x plus 1 minus x log x derivative is 1 x. Okay. Now, after simplification, you take LCM. Then you have this x log x by x log x plus x minus 1. If I put x equals to 1, that is 1 into log 1 means 0, and 1 into log 1 means 0 plus 1 minus 1, so 0. So ultimately again you have a 0 by 0 form. So again the difference by using LHospital rule, again differentiate this x derivative 1 by x derivative, and log x derivative 1 by x and plus log x. Clear? So x as it is, log x derivative is 1 by x plus x derivative is 1, log x is here. Similarly from here, there is x by x plus log x, and x derivative is 1. Again you put x equals to 1, again 1 by 1, that is 1 plus log 1. Log 1 means 0. So from here 1 plus log 1 means 0 plus 1. Okay, so from here it is clear 2, that is after simplification 1 by 2. So 1 by 2 is the limiting value for this expression. Another example from infinity minus infinity, that is evaluate. These are the possible example and as well as most important example for you. Limit x tends to 0, 1 minus x minus 2 by x into e to the power x plus 1, that is 1 by x minus 2 into by x into e to the power x plus 1. Just substitute the value, that is 1 by 0 infinity, 2 by 0, that is infinity, the infinity minus infinity form. If you have this already, you know, if I have a infinity minus infinity form, first you have to transform as a 0 by 0 form. Then what do you do? Take LCM. X e to the power x plus 1 minus 2 by x into e to the power x plus 1. So again you can check, if you put x equals to 0, then ultimately simplify, what you have, e to the power x minus 1 by x into e to the power x plus 1. That is 0 by 0 form. Clear? After simplification, 1 minus 2. Okay, now e to the power 0 means 1 minus 1 0, and e to 0 0 into something means 0, 0 by 0. Again LHospital rule, e to the power x into e to the power x plus 1 plus x into e to the power x. That is x derivative, this e to the power x plus 1 as it is, and e to the power x derivative plus 1 derivative is only e to the power x, so x into the derivative. So if you substitute the value x tends to 0, e to the power 0 means 1, e to the power 0 plus 1, and this is 0. So from here it is clear, you have 1 by 1 plus 0, that is 1 by 2. 1 by 2 is the answer. 1 by 2 is the answer for this limit. Most interesting part, most important part. This form 0 to the power 0, 1 to the power plus minus infinity, and infinity to the power 0. For the three exponential form 0 to the power 0, 1 to the power plus minus infinity, and infinity to the power 0, we find the limits of the function of the form y is equals to fx to the power g to dx as x tends to a. That is when number 1, both fx and gx tends to 0 as x tends to a. Number 2, fx tends to 1 and gx tends to plus minus infinity as x tends to a. And third, fx tends to infinity and gx tends to 0 at x tends to a. So these are the form. If you have, then you have to express, then you have to consider y is equal to something. So that means function to the power function you have, and when you take limit, so your operation of formation should be either 0 to the power 0, 1 to the power plus minus infinity, or maybe infinity to the power 0. Okay, by taking their logarithm and reduce it to the 0 into infinity form. So already you know, in my last lecture I had discussed if you have a 0 into the power form and how to transform 0 by 0 or infinity by infinity form. So from here it is clear, if we have 0 to the power 0 or 1 to the power plus minus infinity or infinity to the power 0. So first taking logarithmic to transform this expression to 0 into infinity form. Okay, then either you can express as a 0 by 0 or infinity by infinity to solve the problem. Clear? Now, these are very good example. Evaluate limit x tends to 0 sin x to the power 2 tan x. Now try to understand. Let y is, that is 0 to the power infinity. Sin x 0, tan 0 is 0. So then is 0 to the power 0. So then what you do? Let y sin x whole to the power 2 tan x. Taking log, that is then log y is equals to 2 tan x log x. Okay, limit x tends to 0 log y is equals to limit x tends to 0 2 tan x log sin x. So from here it is clear, log tan 0 is equals to 0 and log sin 0 is equals to 0. So log 0 is in infinity. So that means you have 0 into infinity form. Now you know, if you have a 0 into infinity form, then either you can transform 0 by 0 or infinity by infinity according to the problem. So here we can express this tan can be cot, that is log 2 log sin x by cot x is equals to 0 by 0 form. After getting your 0 by 0 form, you can apply your LHospital rule, that is 2 sin x by cos x by sin x by minus cos x square x. Again after simplification, what you have? Minus 2 sin x cos x, that is limit x tends to 0 minus sin x ultimately 0. So from here it is clear that limit x tends to 0 log y is equals to 0. Okay, so limit x tends to 0 log y is equals to log of limit x tends to 0 y, then log limit x log y log limit y x tends to 0 is equals to 0 is equals to log x. So ultimately what you are doing, so this limit x tends to 0 log y, you can write log of limit x tends to 0 y. So then from the previous step you can write log of limit x tends to 0 y is equals to 0. What is 0? Log 1 you can write. So from here it is clear, that is log cancel. So you may write limit x tends to 0 y is equals to 1. What is y? You are considering y is equals to sin x to the power 2 tan x equals to 1. So this is the result for this particular problem. Clear? Same way, this is also another example. Limit, these are all very important example for you. Evaluate limit x tends to 0 tan x by x 1 by x. Same. So 0 is the infinity form, infinity to the power infinity form. Okay, so then what you do? Same way, log. So log y is taking log y is equals to 1 by x log of 10x by x. So limit x tends to 0 log y is equals to limit x tends to 0 log 10x by x. Okay, so from it is clear, log this is infinity is 1, log infinity is 0, and this is 0. So 0 by 0 form. Then what you do? You have to differentiate this, that is log derivative is 1 by this, that is x by 10x, and derivative of this, that is x square minus 10x by 1 by using LHospital rule. After simplification, what you have, please check, that is x cancel. After simplification, if you sin x cos x, if I simplify, that is 2x by sin 2x by 2 sin 2x. Okay, so again you have a 0 by 0 form. Again we have a 0 by 0 form. Then that is derivative of this minus 2 cos 2x. Okay, then x, that is derivative is sin 2x plus 2x cos 2x. By using LHospital rule we have 0 by, again you have a 0 by 0, that is 2 into 1 in 2 minus 2 into 1, that is 2, 0, and the sin x 0, this also 0. So ultimate again 0 by 0 form. Again differentiate, that is 4 sin 2x by 2 cos 2x plus 2 cos 2x minus 4x sin 2x from here by using LHospital rule. Now you substitute the value. So from here upper part is 0, numerator part is 0, and lower part is 1 plus that is 2 plus 2 4 minus 0. Then ultimately 0 by 4 is equals to 0. So therefore since limit extends to 0, log y is equals to y, limit y extends to 0. So from here you may write log limit y limit extends to 0 y is equals to 0 is equals to log 1. Okay, so limit log cancel. So limit extends to 0, y is equals to 1. What is y? Limit extends to 0, tan x by x whole to the power 1 by x equals to 1. So this is the answer. So this is the way by which you can transform 0 to the power 0 or infinity to the power infinity to the power problem. Now another from here different types of question you can see. So these are the basic problem I have discussed. Now so here in determined form we can find another type of example where all expressions are given but one unknown is given like this. So you have to find the unknown a. Try to understand. If this is a very there is a chance to get this type of question in your question paper. If limit extends to a sin x minus sin 2x by tan qx is finite, find the value of a and then find the limit. Try to understand. So first your task to find the value. So from here it is clear that your limit is finite, never undefined case. Whatever the situation you have a value. It means from the statement it is clear. Now limit extends to 0, a sin x by sin 2x by 10. When if we substitute extends to 0, that is 0 minus 0 by 0, that is 0 by 0 form. Using LHospital rule, what we have, a cos x minus 2 cos 2x by derivative 2 tan square x and sec square x. Now if you put x tends to 0, that is cos a, that is a minus 2 by a minus 2 by 0. So from here it is clear this a minus 2, that means here a minus 2 by 0 by LHospital if I put here. But try to understand. So ultimately it is undefined case, but from here it is clear, from the question it is given that your limiting value is finite. To convert as a finite, then what do you do? A minus 2 must be equal to 0. Then only you can say 0 by 0 form, because your lower part, denominator part is 0. Numerator part is not become 0. Because if you substitute, a minus 2 is coming. So ultimately a minus 2 by 0, the undefined case, but your limit is undefined. So that means a minus 2 must be equal to 0. So that is a is equals to 2. So be careful about the statement. When x tends to 0, the denominator 3 tan square sec square is 0. But since the given limit is finite, the numerator, that is a cos x minus 2 sin x, should be tends to 0 as x tends to 0. But when you substitute this, what is left? That is a minus 2. So that's why a minus 2 should be equal to 0. So a is equals to 2. So our value a is coming as a 2. Clear? This is also another type of example. Now after getting the value of a is equal to 2, now you substitute the value a is equal to 2 and find the limit. Okay. Now if I put here a is equal to 2, what do you have? That is 2 cos x minus 2 cos 2x by 2 tan square x into 1 plus tan square x. Now x tends to 0. Ultimately there is 2 minus 2 by 0. Ultimately 0. Now 0 by 0 form. Now use LHospital rule to find this. That is minus 2 sin x plus 2 4 sin 2x. and here 6 tan x x square x plus 12 tan q x x square x. Using LHospital, now you substitute the value. After simplification, what is coming, that is minus sin x. So here simplification is very, very important. Minus sin x 2 is cancelling, that is minus sin x plus 2 sin 2x is taking as a factor, that is 1 plus tan square x taking common, that is 3 tan x, that is 2 is cancelling from here, that is 3 tan x plus, that is x square is coming, x square is taking outside, okay, from here, that is what is left, 3 tan x plus 6 tan qx. This x square x is representing as a 1 plus tan square x. Okay, very simple. Then again you can check, this is 0 into 0 from here, 1 0, that is 1, this is also 0, ultimately 0, again 0 by 0 form. So ultimately what you have, that is again the difference is minus cos x plus 4 cos 2x by, from here you have 1 plus tan square tan 0 and tan square is equals to 3 that is 2 tan x and sec square x, and from here 3 tan square sec square x. So from an other term in terms of sec square x, so that's why I eliminating this. So here what you get here, you can see 1 plus a derivative, that is here what you are getting, that is 3 sec square x. So ultimately after simplification what we have, minus 1 plus 4, and this is all involved in the higher order of 10. So that's if I multiply, correct, if I multiply after the derivative, if I multiply, then we have this, that is 1 minus 1 plus 4 plus 3 is equals to 1. So that means 3 by 3 is equals to 1. So if you multiply, you can check all other terms involved with 10 is a higher order. So when you put x to 0, all 10 becomes 0. Only one part is left, that is 3 sec square x. Okay, I skipped this one line. This is for you. Just you verify. Next, this is also another good example for you. Find the value of a and b. Find the value of a and b such that limit theta tends to 0, theta 1 plus a cos theta minus b sin theta by theta q is equals to 1. That is your limit is given. So here a and b are unknown, you have to find out. Now limit x tends to 0, theta tends to 0, theta 1 plus a cos theta minus b sin theta by theta q. If I put theta 0, this part is 0, minus 0 by 0, that is 0 by 0 form. Then again you differentiate this, that is 1 minus a cos theta. So from here a minus a theta sin theta, and from here minus b cos theta, and from here a theta square. This is number a. When theta tends to 0, the denominator theta becomes 0. Since the given limit is finite, then the numerator 1 minus a cos theta minus a sin theta minus b cos theta should be 0, as theta tends to 0. We get 1 minus plus a minus 0 minus b is equals to 0. That is 1 plus a minus b equals to 0. One relation is coming. Again, suppose you have a 0 by 0 form, you are considering this. Again 0 by 0 form, because there are two unknown. So lower part is 0, upper part is non-zero. So that means, but your limit is finite, is result is 1. So that means upper part should be 0. So that means 0 by 0 form. If I have a 0 by 0 form, then we can again differentiate. Using LHospital rule, minus a sin theta, a theta cos theta plus b sin theta by 6 theta. If I put theta equals to 0, so this value is 0, 0, this is also 0, 0 and 0. So again you have a 0 by 0 form. Now again differentiate by using LHospital, minus 2a cos theta minus a cos theta plus a theta sin theta plus b cos theta by 6. So from here it is clear that if you take limit, what you have, that is minus 3a plus b by 6. Your limit is coming, this is a finite result, minus 3a plus b by 6. But what is given? Your given part is limit theta tends to 0, theta into 1 plus a cos theta minus b sin theta by theta q is equals to 1. So that means this minus 3a plus b by 6 should be equal to 1. So that means you are getting that is minus 3a plus b is equals to 6. Another equation you have a plus a minus b is equals to minus 1. Okay. Okay. So from here you have that is a plus what is b from here? What is b? B is equals to 1 plus a. Okay. Now you check, try to understand. Please check carefully. So what you have? 1 plus a is equals to b. Already you have from equation number 1. Already you have. Here you have minus 3a plus b is equals to 6 you have. So ultimately you have minus 3a plus 1 plus a is equals to 6. So ultimately you have minus 2a is equals to 5. So ultimately you have a is equals to minus 5 by 2. Clear? Okay. So if I substitute the value, so from here it is clear that your a result is coming minus 5 by 2 in this. Okay. So if I put, already you know, b is equals to 1 plus a, that is 1 minus 5 by 2, that is minus 3 by 2. So ultimately you have a is equals to minus 5 by 2 and b is equals to minus 3 by 2. So this is the solution of this particular problem. Thank you. So this type of problem you can see in your question paper. For better understanding, just you have to check whether you can solve any workout examples or from exercise example. If yes, so that means your concept is clear. If not, again you have to review this lecture for better understanding. Okay, thank you.